Hello again. For this video, we're going to talk about factoring special products. And our goals here are to factor binomials that are difference of squares and factor trinomials that are perfect squares. And we only have two vocab, difference of two squares and perfect square trinomials. For the first one here, we have a sum and difference product, a plus b, a minus b, and that gave us an a squared minus b squared, which we called difference of squares. So if we had difference of squares, these two can be factored back into this form instantly. You'll know if you have difference of squares because the first number will be a perfect square, the second number will be a perfect square, and there will be a subtraction between them. So we're going to set this up as two binomials. We're going to take the square root of the first one, which is 9v, and I'm going to put that in the first position of both. I'm going to take the square root of the second one, and that would be 8w for both. In order to make it a difference of squares product, we have to use a sum and difference. So one of them is going to be plus, the other one's going to be minus. So plus here, minus here, and this is the factored form of the difference of squares. For part B, we're going to do the same thing again, set up the two binomial parentheses. This is a perfect square, and the square root of that is 1, so I put a 1 in both positions. Both of these are perfect squares, so I take the square root of those, and I get 12q, and I'll put those in both positions. And to make it an actual difference of squares, one needs to be a positive and one needs to be a negative, so plus and minus. And this is our factored form. You may want to write this down in your notes. In an earlier video, we said you had to factor completely, which means you may have to factor more than once. This is a common instance when we have difference of squares. We have a perfect square here and a perfect square here. So we set up our two factors, and the square root of x to the fourth is x to the second, and I put that in both positions. And the square root of 256 is 16, I put that in both positions. I make one of them positive and one of them negative. But what we need to realize is after doing that, I have another difference of squares right there. So I want to bring down my x squared plus 16. And then I'm going to set up two more sets of parentheses to factor out this remaining difference of squares. And the square root of x to the second power is x. The square root of 16 is 4. And to make them a minus in the middle, I need one plus and one minus. So in this problem, we end up having 1, 2, 3 binomial factors instead of 2. This is fully factored. Now we're going to try to factor perfect square trinomials. Remember, perfect squares are anytime you take a number and times it by itself, like this right here. We have a plus b times itself, and it produces this pattern of a squared plus 2ab minus b squared. The second pattern is to have an a minus b times itself, and the only thing that changes is the minus right there. For a trinomial to be factorable as a perfect square, the following must be true. The first term must be a perfect square, which this is. The last term must be a perfect square, which this is. The middle term is 2 times the product, so twice the product of the square roots of the first and last terms. So the square root of this one is a, square root of this one is b, and then times them together and then double. 2 times ab gives you the minus 2ab in the middle there. Okay, so now we want to identify a perfect square. Take a look at this first number here. That is a perfect square. Take a look at the second number here. That is a perfect square also. So I take the square root of the first term, which is going to end up being 2j, and I times it by the square root of the last term, which is going to end up being 4. And if I end up multiplying this whole thing by 2, so it's 2 times a times b, it should give me the 8j in the middle. 2 times 2 is 4. 4 times 4 is 16. So this ends up being 16j, which does not equal 8j. Therefore, this is not a perfect square trinomial. Okay, so let's see if we can recognize and factor a perfect square trinomial. I have both the problems at the top, one with a plus and one with a minus. You'll see this one over here has a minus in that position, and so does this one, so it's possibly matching the second one. However, we need to find out, is this a perfect square here? It is, and the square root of that is 6h. Then we look at the last one, is that a perfect square? It is, and the square root of that is just 1. And then if I multiply both of these by 2, because I've got to multiply this a times b by 2, 2 times 6 times h times 1 gives me 12h, and you'll see it matches the middle one, which means this is a perfect square trinomial. Now, factoring a perfect square trinomial is real easy because it is a single binomial times itself, or binomial squared. So what goes in this first position is the square root of the first number, which is 6h. What goes in the second position is just going to be the square root of the last number, which happens to be 1. And this sign right here, this middle sign, is always the sign in between. So 6h minus 1 squared is the factored form of our trinomial.